Sam Madden is the computer science head of the Electrical Engineering and Computer Science Department at MIT. He's the faculty director of the Systems That Learn Initiative, co-director of the Data Systems and AI Lab. Thanks for being here.
Thanks for having me.
So let's talk a little bit about the company that you started. And it began with this kind of kernel of, I think, what was surprising data to you. Do you want to talk about what was that kernel of data that got you going?
Yeah, so the company we started is called Cambridge Mobile Telematics. It's kind of a mouthful. Maybe we can come back to what the company does in a minute. But we started this. It actually came out of the work that I had been doing as a graduate student. So this was back in like the early 2000s. So it was just like people had cell phones, but like maybe you were just starting to connect computers to wireless networks. So it was like wireless wasn't a thing that existed. And we started thinking about this idea of putting little things that were battery powered around the world and like just measuring what was happening in the world. So we called this idea sensor networks at the time. This was work I was doing at UC Berkeley as a grad student, but there was a group of people here at MIT doing similar stuff, including our dean, Anant Chandrasekaran, and my colleague, I'm pointing over here because his office is right through that wall. My colleague, Hari Balakrishnan, we're also working on these similar ideas. And so the idea was like I was at Berkeley, so we were doing Berkeley stuff, like hippie stuff, like measuring. We were like measuring environment in the redwood forest. We like had these like climbed up the redwood trees and put sensors up and down the trees and measured how the environment varied at like different parts of the forest using these little sensors with wireless radios, and measuring like earthquakes and vibration on the Golden Gate Bridge. It was like, it was like California stuff. But I got very interested in this idea of how you would build software to make it easy to collect data from these networks of things. That was sort of my PhD thesis. And then when I came here, Hari and I started talking and we got very interested in what it would mean to have mobile sensors. So to go from these sort of fixed sensors in trees to sensors that are on moving objects. And again, this was like cell phones existed, but you didn't have like cell phones that you were general purpose programmable things that you could use to capture data about the world. They were like a thing you used to make a phone call, because it was before the iPhone.
Right.
And so when we started this project, we called Cartel, as in car telecommunications,
Okay.
not like drug
Got it.
cartel.
Cartel.
We started measuring lots of things, but especially measuring vehicles as they drove around. We put little embedded computers with wireless radios in vehicles and then measured all types of stuff. But it was like things like road surface conditions, like are there potholes in the city, and mapping all the potholes in the city of Cambridge, and mapping. We actually were interested in mapping wireless networks themselves. So like how are wireless networks? Where do they exist? Are they open? Are they closed? And then traffic a little bit. We started looking at traffic and measuring what road congestion looked like.
Was there a point at which you looked at the data around cars, I don't know, maybe around cell phones, and you said, well, gee, there seems like a problem here that I'd like to try to solve?
Yeah, I think, as I said, like we started initially really thinking about traffic and road congestion, I think, maybe more than we were thinking about road safety in the academic environment. And we certainly thought about, as I said, we thought about potholes and a little bit about accidents and their effect on accidents and the impact of traffic. But we hadn't, wasn't really till we started the company that we kind of had this thing that just clicked at some point. We started talking to these insurance companies and we kind of all of a sudden understood the potential for this technology, this mobile technology we've been building, to really measure what it meant to be a good or a safe driver.
And just talk a little bit about, for people who have not, seen the data, seen the charts, what does the last, I don't know, 20 years look like in terms of traffic fatalities, traffic accidents? When somebody's able to gather that data and stand back, what do they see?
Well, first of all, probably everybody's kind of aware that traffic accidents are a major source of injuries and fatalities, both in our country and in the world. They're the leading cause of death. In the United States, the leading cause of death for people under the age of 40, alternating with gunshot wounds. So it's a pretty severe problem, and it's a problem that the severity of it goes up and down, but varying a little bit from year to year, but especially beginning with in the sort of mid 2000s, partly I think because of the rise of cell phones and people being distracted when they're driving, also maybe because of the sort of increase in size of vehicles in the United States, and that, of course, like the more massive a vehicle is when it runs into another vehicle, the more damage it causes and the more severe injuries are, has led to actually kind of surprisingly an increase in the number and severity of accidents. And especially in the last 10 years or so, we have not actually seen the kind of decrease that you might have. A lot of people might think this is getting better because we've got airbags, because of the quite successful campaigns against drunk driving. You might think it's getting better, but actually we've seen in the past 10 years that the injury rates and fatality rates are, especially during COVID, they went up, but they're essentially now for the past couple of years have stayed flat and not gotten much better. And worse, the most sort of vulnerable members of our population, pedestrians and cyclists, the fatality rates have also gone up quite dramatically. And so it's a problem that has continued to exist for a long time, and has been, I think it is a real, it disproportionately affects the youngest and most vulnerable parts of our population.
You mentioned in some ways a couple pieces of technology that people might think, like airbags, the anti-lock brakes. I mean, these things are older, but maybe they would be helpful. But in recent years, I also think people might think, well, wouldn't the number of fatalities have gone down? People have so much technology in their cars. Sometimes people have cars that even when they're kind of shifting out of their lane, maybe don't mean to, they're tired or whatever, the car is like, no, like pushes them back into their lane. So how has increased technology in the car not sort of solved the problem that doesn't seem to be getting much better?
I think these technologies do help. I mean, partly those technologies it takes a really long time, right? Because the median age of a vehicle on American roads is something like 12 or 13 years. So that means that 50% of the vehicles on the roads are older than 12 years, right? So that predates any of this kind of sensor technology, the adaptive technology, like, as you said, some of the things like forward collision warning, where your car, some of you may have experienced this, like your car beeps at you and flashes when you are about to run into something in front of you, or the lane departure warning, where it alerts you if you drift out of your lane. I think those features actually probably are pretty protective. We probably, like, there was all this hype about self-driving cars a decade ago, right? And these kinds of predictions that, like, self-driving cars are going to eliminate traffic fatalities and all these things. And I think that obviously was a little bit, it didn't happen, at least it didn't happen fast. Maybe it will eventually happen, but it's not like a transformation in the way that maybe it seemed like it would be a few years ago. But I think a lot of that technology that was being developed has found its way into these adaptive safety systems. And I'm positive about them. I think they do help. I think we don't yet know the extent to which they help. I mean, they haven't affected the top line numbers yet, maybe just because the penetration isn't high enough, or because there are these competing effects like distraction and increased speeding, especially after COVID. We just saw a lot of people kind of decided they didn't need to obey traffic laws. Um, so there are multiple effects, multiple effects that are kind of competing with each other.
So at what point did you see the data and think, I think there's something we could do here? And what was the thing that you thought you could do?
Yeah. So, I guess I can remember sort of at some point talking to some of these people, these insurance companies. Maybe this was like 2010, 2011. It was pretty shortly after we just decided to start the company. And this kind of realization that actually what we had in a smartphone. So maybe just a little bit of background. So we, at some point, especially we started in the academic project when iPhones came out, we started moving everything we'd been doing on embedded computers to phones. So we were building smartphone applications to measure driving, in particular measure congestion and, where people were driving and what traffic looked like. And I remember talking to these people in insurance, and they knew that, for example, hard braking, like whether you slammed on your brakes or not, was highly correlated with your accident frequency. So, like, if you
Mm.
slam on your brakes a lot, you crash more. And that was like a correlation that was known. But the thing that they didn't have was any way to give any sort of feedback to a driver. So there had been some early programs that, for example, would put a little device that plugged into the vehicle, but it didn't have a display. It didn't have any feedback. So it was just a measurement device, which an insurance company could use to do like rate setting, like affect the price of your insurance based on whether you're a good driver or not. But they didn't have any effort to try to change driving behavior or show people how they could be safer. And so it was this, I think, kind of thing that clicked. I mean, smartphones, I guess a couple of things clicked. One was I realized that everything you could do in these little plug-in devices, you could do in a smartphone. 'Cause that was exactly the story of what we've been doing in the academic research. We were building these little plug-in devices and we realized that, to map potholes, we realized everything they could do could be done with a smartphone. So we kind of knew how to translate from these existing classical devices to a smartphone. But then, of course, like you remember in 2010, 2012, when smartphones first came out, it was like people built apps. There's an app for that, right? You were just building apps to do everything. It was like, oh, we could build an app that shows a person whether they're a good driver or not, or where and when their risky behaviors were happening. So it's kind of these two things that sort of clicked. Like we knew how to build these smartphone apps that could do this sensing. And we had this idea that you could give people this kind of feedback. And I think it was like, oh, the accident rates are so closely tied to something that's really simple to measure, like whether the car decelerates, whether you slam on the brakes a lot, and if you could change that behavior, which it kind of seems like, you probably could, because a lot of people might just not be aware of this as a risk factor, right? And then it got us thinking, oh, well, if braking is significant, what are the other things you might be able to measure with this device that might be related to people getting into crashes?
So the original thought was not, we're going to start a company to make sure there are fewer traffic fatalities. No. But then when you talk to people at insurance companies, you realize maybe that could be like the upshot of what happens here.
Yeah, exactly.
And the hard braking part of it, I think people are going to be like, so is the idea here is that you get so close to other cars that you might brake hard, and one time out of every so many times you do that, you get more than a little close to the car, you hit that car.
Yeah, I mean, it's true. Like hard braking is a very, in some ways, it's indicative of a whole bunch of different behaviors, right? So hard braking might be that you weren't paying attention as you approached an intersection, a red light, and you slammed on the brakes when you got there. It might be that you tailgate the person in front of you, and we've probably all seen that person on the freeway who drives 2 inches from the person in front of them and is like tapping the brakes all the time. Those are little, braking events. Of course, sometimes hard braking is stuff that's unavoidable. It's a deer jumps in front of your car or something like that. But the point is that the people who have way more than the average amount of this behavior are more likely to crash, right? And the exact mechanism of the crash, could be different. It could be, again, like following too close. It could be just that you're looking at your phone or messing with your radio and, you slam on your brakes, and maybe 9 times out of 10, you don't actually crash when you slam on your brakes, but, every once in a while you do, right?
And so, by the way, phones are good at measuring if you brake hard. Like, I don't know if people would realize like that a phone is sensitive enough to know how it is you brake.
Yeah. So it's kind of surprising. And I think that was a thing. I mean, first of all, like when we first started talking about this in the insurance industry, people were like, there's no way, they just were highly skeptical that phones were accurate enough, that they were high enough fidelity, that the batteries would last. I mean, there are all kinds of questions. People sort of said, I think they just didn't believe that like the phone technology was ever going to be competitive with something that you plugged into the car. And I mean, fundamentally, I think that's the thing that our company was really successful at doing. I mean, we have, essentially put this existing business, like we probably have, I don't know what, 10 or 100, maybe 20 times the installed base of the previous, these little plug-in devices that were ever there. So, yeah, so smartphones, everybody's kind of are aware that there's something that's measuring the motion of the phone. So there's an accelerometer which measures the sort of motion forward and lateral and up down motion of the phone, and then there's a gyroscope that measures the rotation of the phone. And you probably like the phone has these, like you do things with your phone where you take advantage of this, right? So like you know, rotate the phone screen and it rotates. So it's the gyroscope that's measuring the rotation of the phone, or like Apple has these silly gestures like shake to undo or whatever. I don't know if people even know that's a thing anymore, but you know, you can shake the phone and undo the last action. You know, that's the accelerometer that's measuring that. You play these little games where, you know, roll the marble around on the screen or make the character run through a maze or something. So those are all using these inertial sensors, you say gyroscope and accelerometer, to measure this. And it's exactly the same things that we're measuring from in a car. The challenge in the vehicle, and that's where a lot of our technology is really around the fact that your phone, like we needed this to work in an environment where the phone is not in a fixed and known orientation. So we don't require you to put the phone in a mount up and down and turn on an app. It's just running in the background and
It could be in your
in whatever
purse. It
orientation. It's in
doesn't
your purse,
matter.
it's in your pocket, it doesn't matter. And so what we have to do is figure out how to take that acceleration signal, which is measuring, grab my phone, um, my phone, if we're on video, eh? But you know, it's measuring the axes in the sort of, you know, the three axes of the phone, like out the front of the phone, out the side of the phone, and up and down in the phone, right? And we have to rotate that into the motion of the vehicle. So we have to figure out how the phone is oriented with respect to the forward and backward and left and right axes of the vehicle. And we have to do that constantly because, you know, as you move your leg when you're driving, or if your bag shifts on the seat next to you, you
Right.
know, those are going to change the orientation of the phone a little bit. So you have to sort of reorient. So this, the sort of the algorithmics was around figuring out how to make that work. But yeah, so then you get this signal, and it's quite a fine, very precise signal. So we're getting like 100 measurements a second of the acceleration and deceleration of the vehicle, in its, you know, sort of both forward and sort of lateral left and right direction. And it's extremely sensitive. So it can measure, you know, it can measure signals as, you know, fine grained. Like one thing you can measure with these accelerometers, you can detect that there's like a heavy rainstorm or a hailstorm or something like that much acceleration. Like think of like rain pelting on the like windshield of a car. It like that's something that you could measure, that much vibration, which, you know, you could feel if you're sitting in the car, but it doesn't feel like a crazy motion. That kind of motion would be detectable with these. So something as like abrupt as somebody slamming on the brakes that like makes you go forward in the seat is enough to measure to detect. And like I just should say, like these harsh braking, I mean, when we're talking about the events that we're looking for, it's not like a harsh braking event it's the sort of event we're looking for is really something that makes you feel like, okay, you know, the kind of thing that would make your seatbelt, you know, grab and pull back, like something that you really feel like you know, you had to be restrained to stay in your seat. It's not like just you braked a little bit.
Right.
So,
And you eventually came up with an app, right? And the idea was that it could help you be a safer driver. How did it do that? How does it do that?
yeah, so I think first of all, we went beyond this idea of harsh braking. So you realize there's all kinds of things that you could measure from a phone. Um, there's obviously like the opposite of harsh braking, which is crazy acceleration. So people who accelerate way too fast. Um, there's, you know, turning, like people who go into corners really fast. But then there's all kinds of other things you can measure. These sensors are so sensitive. So one thing that's turned out to be really important was measuring whether people were using their phone while they're driving. And so we can't tell the Apple and Google don't let you see what apps somebody is running, but you can tell from these inertial sensors whether the phone is sort of moving in a way that's like it's held in a hand. And so we have these algorithms that do this. So we understand how frequently somebody's using the phone when they're driving, what their sort of braking and acceleration pattern looks like, and some other, um, you know, things like crazy lane changing behavior, all sorts of things like that. Crazy excessive speeding, like if you drive way faster than the speed limit. They have this sort of whole menu of things that we can measure, and importantly, I think we understand how those are related to your rate of getting into a crash. And so I think that's the other thing to kind of understand that's important about this technology is like these behaviors, somebody who's a bad driver, according to these metrics, like if you're in the, say, if you split people up into buckets from the least risky to the most risky, where you say, talk about the 10% most risky people,
Mhm.
or people who slam on their brakes, you know, the 10% highest percentile slamming on the brakes, they're like 2 times more likely to crash than somebody else. So, and overall, like if you look at all these metrics that we're looking at, it could be as high as 10 or 15 times more likely to crash if you're in that highest bucket of crash
That's
risk.
a lot
So
more
this is a
likely.
huge difference. And the other thing that's super cool about these metrics is that most of them are things that you can pretty much directly control. Like you can choose to not pick up your phone, right? You can choose to not speed. And like you might say, well, I can't choose to not brake, but you can choose to drive at a safe distance such that you won't have as many braking events, right?
And I have to say, as not, not somebody in this business, but just a driver, if you watch people go by, I don't know if you've ever done this, even like when you're waiting across the street as a pedestrian, so many people are looking at their phones. It's shocking. Sometimes I'm shocked that people are going straight, like forward, and not just going wildly, but they're just reading something.
Oh yeah. Yeah. And I mean, I like to play this game where you drive behind somebody and like, I bet that person's on their phone because they're driving I mean, looks like they're drunk, or you would, but it's almost always they're looking at the phone and, they're doing this. And the problem is you just start to kind of drift off and then they'll jerk back, it's really, I mean, I think as you say, it's pretty obviously not a safe behavior to be engaged in.
So you're doing this incredible measuring of all these different things that are indicative of like how likely you are to get into an accident. But there's obviously two groups of people that you have to convince to, listen to you. One is insurance companies and the other is people, because I don't know, do people want you to be tracking everything they're doing in their car? So talk about the challenge of that.
Yeah. So, it is definitely a challenge, and, so I can talk a little bit maybe I'll talk a little bit about why the insurance first of all, like, I think we're doing this because we think it's good for the world, right? And insurance companies are doing it because, well, like, you might be surprised, I guess it's not surprising, it's kind of is they don't actually want you to get into a crash, right? Like, they
They
if
don't want to pay that claim.
if you
They don't
pay
want to
them
hear that your car was
$1,000
total.
right,
Yeah.
if you pay them $1,000 a year and never get in a crash, you're like, your money.
It's the best business model, right?
Right. So they really want to know who's not going to get in a crash, and they really want you to not crash. Right.
Okay.
And so there's a very cool positive incentive for our company, and I think for in general this kind of business, which is that like it's in like people don't want to crash, insurance companies don't want you to crash, and so whatever we can do to make you not crash is good. Um, and so I think a lot of people, when they hear it presented that way, feel like, oh, okay, I understand why this technology is important because it's helping me to not crash, or oftentimes helping my family to not crash, right? It's like helping my teenage driver to not get in accidents, right? And I think that's a very compelling message. This is not about tracking exactly where you drive or doing some analysis based on that. It's about understanding, what the factors are that are risky, and then trying to present them to you in a way that is actionable. And so the insurance companies typically will do this through a discount. So they say, you may have seen like Aaron Rodgers, don't mess with my discount. That's like a State Farm program that is based on our technology that's, using smartphones to measure whether you're a good driver. And so if you're a good driver at the end of every 6-month period or whatever, you get a discount, and it can be significant, like a couple $100. And I think that's obviously financial incentives are a way to get people to engage with this. And one thing we spend a lot of time doing at the company is thinking about how to sort of, I don't like this word, but gamify this like driving, right? How do we turn this into a thing that makes people want to engage and be better drivers? And that takes different forms for different people. So like for some people, it might be a financial incentive. One thing we found that works actually better, like the problem with after a 6-month period getting a discount is it's kind of very removed from your day-to-day behavior. And so, if it's at the end of 6 months, you have to wait a long time before you get that feedback, and you might only engage right around the time when you get that feedback. So trying to make it much more granular, like you might get a reward based on like a weekly behavior, or even like, a daily, okay, I did it. I earned my points for today. And by earning my points for today, I know that I'm, getting a few dollars towards a whatever it is, a gift card or something. We find that those kinds of financial incentives, when you look at really trying to change behavior, are actually quite a bit more effective than this sort of, longer term, you get a discount kind of a thing. That's the way. I think that discounting thing is partly done because of that's like the easiest way to work within the sort of regulatory framework of how insurance is sold and priced in the United States. But these kinds of very fine-grained rewards turn out to work better. But then other stuff that you can do, like you can imagine, have a leaderboard with your family or your
Hmm.
coworkers to see who's a better driver, or and you see some of these R apps and other safe driving apps out there that do those kinds of things. So thinking hard about how to incentivize people to change, and then understanding which incentives actually work best is something we spend a lot of time working on.
And do you see the numbers of drivers around the world who have this in their car growing a lot, or do you hit a lot of resistance in terms of people worrying about privacy or?
Yeah, so I think, I remember when we started the company, it was like, if we could get 1% of the drivers in the country on this, it would be great. And I think we're well north of 1% of drivers. I think it's over 10 million people, probably, yeah, over 10 million in the United States who are using this technology, and worldwide. And we're not the only people who provide this kind of technology, but I don't know the exact number worldwide, but many millions of people who use this. Um, and I think a part of it is, yeah, but there's a privacy concern. But as I said, I think it's this message of it's about safety is one that seems to resonate with people. And I think there obviously are going to be some people who are going to choose not to use this technology if they're not, if they're not comfortable with the idea of their insurance company having this. But um, insurance companies have a lot of data about people in general, and I think if you look at the way insurance companies market themselves and advertise themselves, they're trying to establish a sort of a trust um, with their customers. Like that's a very important part of it. And so I think all of our insurance customers treat data privacy very seriously. It is not a business. This is not about monetizing this data for some purpose besides just the pricing of insurance. So I think, that's I think it has. I think it has been like the sort of the numbers proved or demonstrate that this is like a thing that a lot of people are actually pretty comfortable with, and people respond to financial incentives, right? I mean, your insurance is a big cost for a lot of people, and the price of insurance has gone up. So
So let's talk for a minute about kind of like business infrastructure. I think that obviously so many businesses across the spectrum, no matter what the sector, are thinking about how they integrate AI into finance, into healthcare, different things. I mean, it's interesting because you're both in academia, but you also have been working on building a business for many years. Um, how would you say, if at all, you incorporate AI into your business, and like what has that journey been like?
yeah, sure. I mean, so of course AI is like it's the buzzword du jour, right? But the idea of I mean, at some level, a lot of the things that the companies does are based on algorithms that you might call AI, right? So these are, for example, like one kind of thing we have to do is that a smartphone is not obviously you can be in a car in a smartphone where with a smartphone where you're not the driver. So one of the things we need to do is to understand whether somebody is actively driving when they're using the smartphone, and so there is a what we traditionally called machine learning algorithm, but an AI algorithm that is trying to classify whether or not you were the driver on a particular trip, because you might get into you know you might get in the car and your spouse might be driving, or in some cases we have a sensor inside of the car that allows us to know whether the phone has a little Bluetooth signal that the phone can communicate with, so we know that you're in your car. But in some cases, these programs don't have one of those sensors, and so you might get in an Uber. The app might still record some behavior that looks like driving. So you have to filter out those passenger driver trips, as we call them, and there's an AI algorithm that does this. There's an AI algorithm that, again, if you're not in your own car, you're on a bus or something, so that looks like driving. So how do you know that it's a bus as opposed to your car. So there from the very beginning have been algorithms that you would call AI algorithms that have been there. I think the modern sort of view of AI, this recent, thing that I guess OpenAI kicked off with large language models, or what you'd call generative AI. The interesting thing about that is that it creates maybe an ability to interface to data with language, or to allow people to engage with information and data in sort of non-technical, non-programmer people to engage with data in a new way. And I think that's very interesting, not only, for our business, but in lots and lots of businesses, and we're going to see things change. So, we're thinking about how this might allow people to engage with things like their risk profile better. So you could imagine if you could have a conversation with your safe driving app about, where are the places where I'm the riskiest, or what are the behaviors that I'm most at risk of. Those
Right.
kinds
Like
of
turning
things.
the data essentially into a narrative.
Right,
Like
that then people can engage with, and sort of turning everybody into a data analyst so that they don't have to go write a program to analyze the data, but they can get some insight out of the data that goes beyond whatever prepackaged, presentation of the information that the app has in it. And I think there's a potential for that in a lot of places. And then clearly, the other part of this, I guess, that these algorithms do is much in the way that, you know, um, ChatGPT or these large language models have been able to model the behavior of language in such a way that they can reproduce very natural language, or imagine, sort of have a conversation like a person, or create new language that didn't exist before. That's the generative part. They can generate language in a way that, I think is frankly very surprising. I think it's very interesting to think about the implications for that sort of ability to do generative AI might be on data that goes beyond natural language. So what you can do with these models is to create representations of all types of natural behavior, not just language, but imagine you could have a model that has a representation of driving behavior, right? And then maybe it can understand what driving behaviors are safe or not safe, right? Or, same kind of thing we see a lot of these applications in medicine or biology, right? You can create these models that understand the structure of proteins so that it can, for example, generate new types of proteins, or proteins that might, have some particular match in some kind of biological setting, or function in some kind of biological setting, because it understands the ways in which, say, proteins are driving, or language are structured. So you can learn these very, very complicated patterns that, and then not both generate stuff that looks like a real world complicated phenomenon, but also use that generative capability to sort of, understand or classify different types of behavior that you might see. Like you could say, is this driving safe or unsafe? Because it understands the driving in some sort of very fundamental way. It can, like, as a representation of the driving. I don't know if
right,
that
right.
kind of makes
Yeah.
sense.
And then I wonder, I mean, and this answer could be tied into your own company, CMT, or it could be from other conversations that you have. But is your sense that within companies that AI is radically changing the lives of like programmers, or how things happen? This not customer facing necessarily, but like how things happen inside.
Oh yeah. This maybe more with like computer science hat on, but it's like, it's definitely changing the way that we program,
Mm,
right? The way that people experience, if programming used to be this, you were very worried about the details of like where each semicolon goes, or where each bracket goes, or whatever. And these models just, they're able to generate programs that are uh, remarkably complicated and sophisticated, right? So I think, it's a big question, I guess, that in academia we have, is like, what does it even mean to teach
right.
programming, right? Like, do people need to understand all the syntax of the programming language that they're writing, the detailed, where does the semicolon go kind
Right.
of thing? Or do they even need to understand, these things are good enough that you can say, I want a program that I don't know what, like, make me a program that visualizes this data set as a bar chart or something, and it can just do it and it can generate it. And so do you need to teach people how to like program at that level? I think it's gonna be really interesting to see what it means for academia. I think, there's clearly still, we'll see where AI goes. I mean, I'm somewhat skeptical that you're going to ever replace humans in the enterprise of like engineering big, complicated pieces of software, because those engineering exercises are like, if you've ever worked in the software engineering organization, it's like, I mean, it's probably like, I don't know, deciding a podcast to produce or something, right? It's like there's a lot of people who are involved, and it's really about getting people to agree on
Right.
what should be built, agree on how it should be built, agree on, who's going to do it and when they're going to do it and what the priorities are. And, there's a lot of very human processes that are a part of it
There's a
that
lot
you're
of
never going to
meetings. I mean,
replace. Yeah.
if you talk to somebody who's an executive at a software company and you say, "What did you do today?" Like,
Very.
be in meetings. Like, how much software did you write? No, not
Very
much,
much.
right?
And not even executives, but even people who are, like a senior software engineer in a company might probably would spend a lot of their time thinking, not actually writing the lines of code. But it's definitely the case that these models are changing those lines of code. And so I think, as we think at MIT about training software engineers, I think it's a really interesting question about what you need to teach people. And I mean, I guess I kind of think of it like I guess the best analogy is like calculators or something, right? Like you still need to understand how to do arithmetic, but most of us, unless we have like school age kids, probably can't remember how to do long division anymore, right? Because if you need to divide two numbers, you just break out the calculator and do it. You understand conceptually what you're doing, but you don't need to understand the procedure of doing it anymore. And I think that's a pretty good analogy. Like we don't necessarily, you kind of need to understand what it means to write a program, but maybe you don't need to be able to write the exact perfect 10 lines of Python code the way they used to. And that's going to change how we teach programming, how we evaluate programming, who we hire and how we hire people. I mean, it's pretty disruptive. And it'll be really interesting to see what happens.
Yeah. I mean, do you need to know grammar if you have autocorrect?
Right,
There's a lot of things
exactly.
that
Or
you
spell
right.
checking,
Right,
some of those
exactly.
things that, we've had but I think those analogies are good because I think they maybe help us to like, I mean, obviously it's different. And I know people are like, oh, this is way more disruptive than any of those other things. But, we've had technology that has changed the way that we, you know, do business before.
Right.
And, we've kind of figured it out. And, I guess I think one analogy that's maybe good is like the transition from low level programming languages to high level programming language. So, in the 1980s or 70s, right, people would have, or early 70s, I guess, people would have programmed in assembly language, like some very, very low level language that was extremely hard to understand, that didn't look like natural language at all. And we've built up more and more and more sophisticated programming languages. And you might have thought that that would mean that we would need fewer and fewer programmers because one programmer can produce, so much more code. But instead, we have a lot more programmers than we had before, because now everybody's a programmer and we can write, a million times more software applications. And so, I think there's an optimistic view of generative AI that is like that, where it turns everybody into a programmer. Now, anybody, you want to build a little web app to keep track of your, personal finances, you don't need to use Excel anymore. You're just going to go build it, and it'll be a custom app that does exactly what you want and has exactly the features you want, and you can customize it. And, that's like a pretty cool, empowering view of the world, right?
I'll ask you a data sort of quandary question that I have heard a lot of business leaders debate about. And I don't know if this has come up for you. Obviously, you have like huge amounts of money being spent by like Amazon, Google, Microsoft to be able to help you, little or company, handle your AI. But I know there's a lot of hesitation when you have sensitive data, which you do, which is part of the reason I asked this. But you hear this coming up from people in healthcare, in finance, because they all have very important sensitive data that they don't really want out there in the world. Do you think people worry about turning to these other providers, though they have like very compelling offers, because they're somebody else, they're another company?
Oh yeah, no, absolutely. I mean, I think people are and that's part of why. Well, so that if you're familiar with the AI landscape, right, there are these like hosted models like OpenAI. And I think a lot of companies are even despite OpenAI has, initially they said, oh, anything you upload is, potentially going to be used for training. I think they realized that that's probably not a kind of a non-starter for any kind of commercial use of this thing. But, I still think companies are very cautious about wanting to put their data into OpenAI. And so they prefer to use models that they are, know are not going to be trained on the data that is uploaded to them. And so those are these open source models like, Facebook's Llama models, or that DeepSeek model was an example of a model like that. It's a model that you can go download it and, you run it locally on a machine that you control, and that anything you put into it isn't getting sent off somewhere else, right? And so I think there's a lot of people who would prefer to use models like that. I mean, certainly at CMT, that's our preference.
Versus using like that kind of
Versus
Amazon
sending, yeah. And Amazon, Amazon has done something good, which is that while they do have their own models that they're developing, they also host these not open source, but open weights models for you. So you're running it on Amazon infrastructure, but it's Amazon infrastructure that you essentially control, right? So you have a lot of confidence. Like, everybody's people trust Amazon that the data that is on their machines and Amazon is really their data, and the data is not, right? I think a lot of people have like gotten comfortable with the idea that Amazon machines might have the data on them, but that it's really their data, and Amazon is not going to look at the data. And Amazon is very careful about not, whatever data you have on their machines, they don't even have any ability to access it, right? It's just they're running the machines for you. And so if they're running the machine that's running the AI model, that doesn't mean that they have access to the inputs or the outputs of the model at all. So,
and you can understand the incentive also to be really careful for this Google Cloud or AWS, because if they're not careful one time, it's kind of the end.
Yeah, this is their business. Is like they've spent decades trying to convince people to trust them, right? And in 2010, when Amazon, first came on the scene, there were a lot of companies that said, "Oh, we'll never, we're on-prem only. We're never going to go to a cloud model." And you see more and more and more, even in finance and healthcare, people going to the cloud because it's cheaper, it's easier, and I think a lot of people kind of probably have concluded that maybe Amazon's actually better at keeping their infrastructure secure than they are, right? Like it's hard to build a big secure cluster of machines and host it yourself. And so, it's been that trust relationship has been one they've worked really, really hard to build.
So finally, let's just come back to the very beginning and this kind of data problem or issue that struck you when you realized like, oh, there's all these fatalities that happen every year from driving. I think we might be able to address this. Where do you think we are now? Has the tide turned at all? And where do you feel like, I don't know, like where Cambridge Mobile Telematics stands in all of this?
Yeah, I mean, like I think I look back at what we've done, and we do have millions of drivers on this platform, and we can translate that into like hundreds of thousands of crashes, thousands of lives that have been saved as a result of this technology being put out there. So I think that's something that we feel really good about as a company and a mission. And a lot of our employees are like, I think, like working for us because you're working on something that has a directly measurable effect on lives. I mean, we still have a long way to go on traffic safety. And it'll be really interesting to see what, some of these autonomous vehicles and other kinds of AI things, to bring it back to AI too. I think it'll be cool to see if and when that comes to fruition and how it changes road safety. I hope all these things together, do make a big difference. And then yes, yeah.
Do you worry about an increasingly corrosive effect of phones, or do you feel like, I mean, there are public safety campaigns like Don't Text and Go.
Yeah.
So I just wonder if when you look at the data, you probably have a better sense of this than almost anybody. Are people using their phones more as they drive or less? And you could kind of like argue it either way.
Yeah. So we saw, again, with COVID, it was just like terrible. Like everything got worse. So speeding was worse. Phone use was worse. Braking was worse. Phone use has sort of, I think, gone back to the level that it was at in 2018, 2019. There again are some competing effects because modern vehicles have these very immersive displays in them that mirror a lot of what is happening on the phone. And because what we're measuring in the phone is the movement of the phone itself, not the interaction with, even if you have like CarPlay or whatever in your car, we can't see that as an effect. So I think there's been some shifting towards interacting with the vehicle, but like it can't be any safer to be poking at this giant touchscreen in your car than it can be to be poking at the
Right,
phone
right,
in your
right.
pocket, right?
Right.
So, I do worry about it. I think the other thing I worry about it is that and one of the challenges with this autonomous driving technology, of course, is that like it gives you this false sense of security, like, oh, I've got this thing that's my autopilot that's just going to drive me from here to there. But that autopilot expects you to be able to take over at a moment's notice, right? But if we all get kind of complacent and decide that it's safe and I don't need to do anything, it's fine for me to respond to an email or, check my Facebook or whatever, right? That's pretty bad because you're not going to be able to, it takes you many seconds to be able to take over when you're not paying attention. And the car expects you to respond very quickly. So I worry a little bit about that. I think we haven't figured out those kinds of human interface kinds of questions with these technologies. I mean, when the autonomous vehicle is like 100% autonomous and trustworthy, then that's great. But the kind of supervised autopilot thing that seems to be what is currently being offered, I think it's not clear to me that it's actually safer.
Do we have enough tech-enabled solutions to solve the tech-enabled problems?
Right.
That's
It's a little bit,
that's the ultimate
it's
question,
always
right?
like, we're a little bit like, we use smartphones to measure whether smartphones are a problem. Like, and, to be fair, we don't like ask you to look at your driving score while you're
Right.
driving, but still, like it's a little bit of
It's
irony
both, a
there,
little bit
yeah.
of both. Yeah. Sam Madden is the computer science head of the electrical engineering and computer science department at MIT. He's part of CSAIL, a co-founder of Cambridge Mobile Telematics. Thanks for being here. This is
Awesome.
great.
Yeah, thanks, Kara.